I did a video 2 years ago on secure messaging apps, and I made several recommendations on there. But one that I was specifically interested in was the Session app, and I remember saying that we needed to keep an eye on this app. I had good things to say about Session even back then. At the time, Session was still fairly new and was in a very basic form, and I knew that a future version would climb up on my chart quickly. Well, after 2 years, I'm re-reviewing Session, and I will tell you now that if you're looking for a hardcore secure messaging app that really understands what privacy means, this is the way to go. Many features that offer a turnkey communication solution are included with the app and makes it a robust solution. I will definitely state that this is one of the best secure messaging apps out there, and with a well thought out approach that was laid out in their original white paper when I read it a couple years ago. Much more private and secure than Signal, and definitely way superior to other popular secure messaging options, including WhatsApp and Telegram. There are very specific reasons for this, and I will be happy to explain all this if you stay right there. Session is a product created by the Oxen Privacy Tech Foundation. Oxen itself, which powers Session, is a cryptocurrency and provides a large incentivized community that can support the infrastructure for some foundational features of the technology, which include low-key net, Session traffic, and the Oxen cryptocurrency itself. I'll discuss the Oxen infrastructure details later so we don't get derailed with minutiae too early on, as this is a complex and robust secure messaging product. You do not need to know anything about the Oxen crypto to use Session. The main issue that distinguishes Session from just about any other secure messaging app is that this is one of the few organizations that truly understand the privacy issue completely. Apps like Signal, for example, can boast end-to-end encryption or E2E, but encryption is only a security aspect. The biggest source of data to intelligence agencies, for example, is not the actual content of the communications, but the metadata. It's distressing that apps like Signal, Telegram, and WhatsApp are driven by a telephone number, a number that you get by supplying ID to a carrier and paid with a credit card tied to a credit report. It is a published identity. A phone number attached to relationships with other people based on call records and contact lists and 2FA lists. The simple act of passing a phone number to some contact you don't already know is already a privacy breach. So though Signal gets high marks for usability, its real purpose is for secure conversations, but not private ones. A private conversation should leave no indication that two people converse at all. That's the metadata. The security is only about the encryption of the conversation itself. I often would recommend Signal only for use by family members or people who already know each other's phone numbers, never for strangers. And I would say the same for WhatsApp and Telegram. WhatsApp is actually quite dangerous. Not only can WhatsApp identify you by your phone number, your contacts are contacts tied to Facebook with a history of metadata based on matched Facebook accounts, which includes relationships, relatives, and childhood friends. So WhatsApp is total crap for privacy. Zuck could easily scan the Facebook database and WhatsApp database and figure out people having surreptitious affairs just from traffic patterns and relationships. That shows you how bad the privacy aspect is. There are also other traces of metadata tied to IP addresses, which again can generate patterns of data that can fully identify people's connections. Now, Session has none of these issues. In fact, the way their infrastructure is set up, it may be the most private and secure messaging platform around if you're interested in a quality solution that completely obfuscates the metadata. Let me jump right into Session's features. First of all, and this is an amazing recent development, Session runs on all platforms. For my testing, I've installed it on Android, Linux, and Windows. It is available also on iOS and macOS. On my Google phone, I was using F-Droid to install Session, which is a big plus right there, since this means this version has no connection with Google Play. But still, it can be used on normie phones using Google Play Store or the Apple Store. The advantage of having this global compatibility, including even the Google phones, is that there is no learning curve with different platforms. The UI is the same for all. So once you figure out how Session works, the rest is easy. Session can be intimidating the first time you encounter it, since you are identified by a session ID, something you create on your device when you first install an app. The main hill to climb, though, is understanding what the session ID is. So the session ID is actually a public key. This intimidates a lot of people because they don't understand this. It is unique to the session instance, and it is the main identifier that is used to exchange a contact. So two people needing to converse have to exchange session IDs. But this stymies many people because they don't know how to pass session IDs. It is easy, for example, to state to a friend that your XMPP contact is robtest@xmpp.brax.live. It's easier to remember. A session ID looks like this, a bunch of hexadecimal digits. This admittedly is the biggest hill to climb with Session, but I will make this easy for you. This session ID does not have to be private. It is a public key, and you can publicize it to your friends and contacts through secondary means of communication, like in a social media profile. You cannot attribute the session ID to a particular person by watching session traffic. With a collection of session IDs, it shouldn't be possible to determine who's talking to whom by observing the network. There's actually a way to generate a username that you can use to give to your contacts instead of the session ID. The procedure for getting this username is fairly complicated, and it's not something I expect a regular session user to figure out. To get this username, you need to really get into the Oxen ecosystem by installing the Oxen wallet. This procedure is not in the Session website, but it is described on the Oxen website. Maybe Session can come up with a way for people to generate a free and optional short handle that can then point to the session ID public key like they do with GPG public keys. That could ease the acceptance difficulties. As a public announcement, you can set up an account on my BraxMe app and publicize your session ID on there in your profile. You can set up multiple session apps on multiple devices and use the same session ID, and they will sync with recent messages. I presume based on messages still stored temporarily on the Oxen nodes. Remember though that this is a super secure app, so there is no central server that has your messages permanently. Aside from transient messages, if you lose your session install, you will lose all your older messages. So a backup is to have multiple installs of Session on different devices. Now I said that you cannot watch the session traffic on the network and start making metadata connections using session IDs. This is the time to introduce the session communications infrastructure, and it is quite different than Signal or WhatsApp. Signal, WhatsApp, and Telegram run on centralized servers. The problem with centralized servers is that omniscient players like the US government, three-letter agencies, can observe traffic flow from the world, and using time comparisons are able to triangulate conversations and traffic by location. This is a very dangerous kind of metadata that only advanced players in privacy can understand. Session, first of all, runs on the infrastructure of Oxen server nodes, which are independent operators who support the Oxen cryptocurrency. And similar to Tor, Session uses an onion routing scheme similar to Tor. This protocol is called LokiNet and runs on the Oxen network. So the first thing obfuscated in Session traffic is where the traffic is coming from. Your message will be jumping from server to server and even multiple chains of servers before it gets to the message destination. And the encryption onion layers ensure that the traffic is not visible to any of the servers processing the message. This is a well-known technique for those that are familiar with Tor. This is an encryption step not done by other messaging apps. The end-to-end encryption itself on Session uses the Libsodium library. People in cybersecurity know about Libsodium. It is a well-supported cryptography that is maintained by a community outside Session itself. So we will not expect some unusual bugs in the cryptography used based on some proprietary protocol. I use Libsodium myself, though this is a really good choice. Now the actual encryption is based on the private key of your Session instance, and that is kept in your local machine. So as with anything else, security of your device is key to the security of your conversations. Fortunately, you can set a password on your session instance if that is important to you. This is a feature missing from many messaging apps. So if someone can get a hold of your phone, for example, they can see your messages. This attack is a well-publicized approach for reading Signal messages, for example. Just hack the device and then run Signal on it. Session is a full-featured communications app and goes beyond just simple text messaging. However, you need to understand how these features are supported in the infrastructure, as they are not as private as the text messaging side. This is not different from Signal. All messaging apps have to compromise when you start handling multimedia, since various protocols used by media like video, for example, can leave a trace. What is unique about Session's approach, though, is that message network traffic is routed through the onion routing, so it's like using Tor at all times. So observations of traffic cannot be done by external players. So back to the multimedia. One of the unique capabilities of high-level secure messaging apps is that there's no permanent central storage of messages. However, before the messages are delivered, they can be temporarily stored en route until the receiving device is connected to the network and can receive the message. In the case of the encrypted text messages, this can be routed to a multitude of servers provided by the Oxen network, and the messages themselves are of course E2E encrypted, and they appear to be stored for a period of about 2 weeks. The difference with multimedia, let's say images, video, and sound files, is that they are maintained on session servers until the recipient receives them. Thus, this is a centralized part of the infrastructure. Yes, it is a compromise, but Signal is already centralized with this, so it is a common approach. Multimedia files are limited to 10 megabytes, by the way. If you want to do voice calling, that is actually done via the standard WebRTC protocol. At the moment, this is not onion routed through the LokiNet. However, it is all peer-to-peer, so there's no central server involved. Caution though, because all WebRTC calls require a server to handle connection signaling, like turn servers. So this is not 100%, but it is no different than Signal. It depends on your threat model. In a hyper-secure environment, I think that text-only communications would be the way to go. For normal communications by average people, the usability provided by multimedia support is probably essential for acceptance by a large number of people. But back to the features like voice calling. This is really convenient. Voice calling can be done on any of the devices, so I can have a voice conversation between my Android and Linux computer. But I'd probably use a VPN if I want to obfuscate WebRTC traffic more. You can also send voice recordings as attachments. This is more secure than a real-time phone call and is something that can be done in a hyper-secure model. The voice recording would be E2E encrypted. Now, I did mention some basic requirements of a good secure messaging app. One of those requirements is that the app be open source. Many of the alternative secure messaging apps, including Signal, are only partially open source. Often there is no open source of the server code. Session is completely open source, including all the versions for all platforms. The whole infrastructure, including Oxen and the LokiNet onion routing, is also open source. Except for the centralized multimedia repositories for temporary storage, there are no centralized servers. All session services are run by the infrastructure of the Oxen nodes. I would point Session as the way to go for people needing end-to-end encrypted communications with people they don't necessarily know well, though it is of course excellent for everyone. So to me, it meets the criteria of all-purpose communications, from normal person's threat models to hyper-secure. This is the use case where Signal fails. If someone wants to talk to me securely but doesn't want any detectable metadata that reveals I'm talking to an identifiable individual, then Session is superior to just about any other solution. Again, its main benefit is the understanding that metadata is dangerous. Revealing phone numbers between two parties can expose tons of metadata to both parties and to third parties. All it takes is for one real phone call to occur. Revealing emails can do the same thing, revealing IP addresses as well. Again, the risk is not only between the two parties, but this data is easily retrieved by third parties. If I were a journalist wanting to obfuscate a whistleblower source, then session would be the best solution. Just as an example interaction, two people could initiate contact on my Braxme social media app. Braxme is a no identity app, which means if two people set up two new accounts and conversed, I would have no way of knowing who is who, since an identity is not recorded and IP addresses are not tracked. And there are no email addresses or phone numbers. Then the initial conversation within the app could be an exchange of session IDs, or it could be implied by the publishing of the session ID in a profile. And then the session conversation started. Careful though about sending session IDs in secondary communication channels like email, since it would be possible for session IDs to be recorded externally by three-letter agencies and connect people outside of session itself. In other words, it depends on the threat model. Let me generalize how to install session and specifically focus on quirks for some platforms. If you're installing on iPhones and Google Androids, there's nothing special you have to do. You can just find the Session Private Messenger app on the Apple Store or the Google Play Store. If you're on a de-Google phone, the preferred way of installing Session is via the F-Droid store. This is the most secure version. The disadvantage is that you don't get to utilize notifications, which gives you faster feedback on incoming messages. On a computer, you can go to getsession.org and the download link gives you files to download. You can also download the APK of the Android version directly. Just download and click on the installer and it will install just like any other app. On Linux, it comes in an app image format. App images cannot be installed by just clicking on it, so this can be confusing for Linux users. I happen to be running on Pop! OS, which is a fork of Ubuntu, but to run the Session app is simpler than you think. You see, it is not necessary to even install the Session app. Just move the app image file to wherever you want to call it, then change the permissions on file to allow execution. You can do this on the file manager GUI of your distro or use the chmod command on the command line. Then click on it and it runs. Nothing to install. It is completely self-contained. There are a bunch of instructions to install it via other repositories, but that's a lot more complicated than just changing the permissions. After installation and initial operation, you will be asked to generate the session ID. By default, this will be different on each device. You don't have to store the session ID. It is easy to copy anytime you need it. What is hidden in the installation is the private key, and that is really where the security lies. So if this is important to you, go to Settings on Session and set a password for your session installation. Otherwise, your security will be the device password of the device hosting session. You will also be asked to back up the private key using a security phrase. If you store this security phrase somewhere, you will be able to restore your original session ID on other devices. This can allow you to install the same session ID on multiple devices and will act as a backup. If you lose a session ID, you can set up a new session ID and start fresh. The disadvantage to not being able to recover a session ID is that your contacts will need to get your new session ID. Now, there's deep nitty-gritty that I have to go through to give a fuller explanation of the session infrastructure. As I explained earlier, Session is a product of the Oxen Privacy Tech Foundation, which in itself is driven by the Oxen cryptocurrency. Oxen is a fork of the anonymous crypto Monero, so it is based on pretty solid roots as far as anonymity of crypto transactions is concerned. Oxen servers are maintained by individuals that make the money from Oxen tokens. And to run an Oxen server, you have to stake money in it. And Oxen service nodes make Oxen tokens from providing the services to the Oxen network. The main function of the Oxen cryptocurrency is to support the network called Lokinet and Session. Lokinet as an alternative network to Tor deserves a separate video, but here I'm just introducing it as an essential element of the Session infrastructure. A regular user of Session does not need to understand this, but those serious in understanding the advantages of Session would find value in this, and you can read the details of Oxen on the Oxen site. In my past video, I recommended XMPP as the best solution for a metadata-free option for communications. And as a solution that respects metadata, I can still recommend XMPP. But let's compare Session to XMPP. XMPP is a protocol, so unfortunately there is no one organization supporting it. This means there are many XMPP apps, and depending on the platform, you will be faced with different apps. Some XMPP apps support all the features, and some support only some of the features, like the latest all-memo encryption method or handling attachments, for example. The UI for each app is different, so it is hard to give instructions to your family because it depends on the app they install. Session has support for all platforms, and the UI is the same for all as I've seen, so that's a big plus. XMPP handles the metadata problem by having federated servers. You can even set up your own server. However, it is possible still to intercept traffic between servers and devices if you're an omniscient party like a three-letter agency. Not easy, but doable. Session, in contrast, uses a Tor-like network, so this makes this a complex undertaking. Session is always E2E encrypted. On XMPP, you have to specifically choose which encryption to use because some clients do not support all encryption methods. This makes Session more bulletproof encryption-wise for an inexperienced user. XMPP is easier to set up because the usernames are easier to remember for sure. If I were a business and I needed to set up quick communications for my employees that is secure, I would still use XMPP. Typically, you'd be able to guess your usernames and you will all have the same server. So there's a different use case for each, but this would be my top two choices. In summary, the biggest roadblock to Session use is the Session ID. Remember that the Session ID need not be private. It's only private if you don't want spam or want to avoid the appearance of obvious Session ID exchanges in surveilled channels like email and texting. But in most any other context like regular use, you can reveal it publicly. There! Roadblock eliminated. Friends, I offer solutions to protect your privacy. The Brax 2 Privacy Phone is completely big tech free, open source, no tracking by anyone, and definitely no censorship. Yet it is completely functional for most things we need to do on a phone. Instead of having big tech control your internet traffic, we have a VPN solution, Bytes VPN, DNS free from tracking, and a Tor option. We also have Brax Mail. Why have Google actively read your mail? There is a choice.